Okay, it's 1 o'clock. We ought to start to make sure that we're going to stay on time. Thank you all for coming. I can see that some of you were here for my talk yesterday, slightly different talk on cloud for client services. I've got quite a lot to cover today, so we're going to get cracking. I'm hoping there'll be some time for questions. Please come in if you'd like to. Right, so first of all, I'd like to thank Accountex again for inviting me to speak to you today. What is this seminar about? Firstly, this is professional education. It's not a sales pitch. Who am I? I'm a technical architect. I'm a board executive for some years standing. I'm not a sales director here to make a pitch to you. I'm here to talk about the background of cloud and how it's being used. My own personal background is in physics, software engineering, embedded systems and communications. So I won't be covering things in technical detail, but I do have a technical background. Online 50, I am the founder of Online 50. We're a service provider, we're not a software vendor. We do write software, but it's the software that runs under the covers to make everything work. So what you'll see from us today is information about the systems. We're not here trying to promote any one software solution, but we do obviously have cloud services. Okay, I've been given 3 questions to consider today. So the first is, can cloud computing really increase productivity and reduce costs? The second question is, how are real-world companies benefiting from using the cloud? The third question is, what if the internet fails? Okay, now yesterday I only had 2 questions, so we've got to get a move on a bit today, I think. Okay, so implementing any IT systems can lead to a double benefit. The double bubble, we've called it. So we're living in an era where computers are doubling in power approximately every 18 months due to a combination of the improved chip manufacture technology and the speed the chips process at. At the same time, costs are not increasing rapidly. In fact, if you don't buy leading edge equipment, you'll see prices falling. So if your new IT system, whether it's cloud or not, is able to make people more productive while at the same time being cheaper per person, then you can achieve the double bubble. So what that means is that the cost per unit of completed work, if you like, is going down. You can see here, you're all accountants, I'm sure all of this makes perfect sense. 10% more productivity, 10% less price will give you an 18 roughly % drop in the cost per work item. So, how do we increase efficiency? Any new IT system could increase efficiency. Not all of them will. Somebody visited our stand yesterday, we're just over here, and while we're talking they said, I've visited lots of software providers and I've looked at their software and I've thought, why would anyone use that? Now I can't comment on the individual software providers he was talking about, but newer doesn't necessarily mean better. One of my colleagues recently was shocked to find out that some software we use in our business is free if you use the latest version. If you want an older version, you have to pay. And he didn't really understand this, but then I said to him, if you take the new software, you'll be helping them to find the bugs. If you take the older software, they've already found and fixed the bugs. Now, even though that makes great commercial sense, how many traditional software companies will charge you for the privilege of finding their bugs? And if you find a bug that's then going to cripple your business, what do you do then? Just a couple of examples on that. Recently I saw on LinkedIn an article came up from they're not here, but a very popular large software vendor talking about a remote access system, and within minutes people were coming online saying, this system nearly sunk my business. I hope it doesn't do to you what it does to me. Now that's a bit, for them, that's a bit of a disastrous, and that's the world of instant feedback that we live in. I'd like to talk also about a family business that is no longer in existence, which used to be based not far from here, a company called Dudley Stationery. They're a really great firm. They've been going for about 50 years. They were growing and expanding. They decided, probably in the early 90s, to implement a new stock control system. Obviously, they're supplying stationery. Stock's very important. Robotic picking, everything. Within 6 months, they're out of business. Other companies that I've worked with, I was nothing to do with that project, just put my hands up. Other companies that I've worked with, I work with Pertec. You may have seen them. They're a franchise organisation. They do hydraulics. You often see their vans around. They were looking at a similar system. We'd actually done some work for them to provide a plug-in running in the franchisees that would integrate with the so the franchisee would run Sage 50, it would integrate with the ordering system at the central depot to do the ordering. That was all going to be replaced. But they, in the process of looking at this robotic system, they got a certain way down the line and then they pulled the plug. Pertec is still going. Okay, if you make the wrong decision with software, it can cost you the business. Okay, it's never too late to pull out of something that's going to be the wrong decision. Okay, decreasing cost, that's the other part of our double bubble effect. Firstly, obviously, it's going to be very important to understand the basis on which you're determining your costs. We'd recommend always that you try and identify total costs, and that's going to enable you to try and complete a like-for-like comparison. That's not always straightforward. Not all costs are explicitly identified. For example, day-to-day disruption to staff when they're diverted from what they should be doing because of IT issues, whether that's with a cloud service or an in-house service. Recently, I met with a company that were considering moving all of their IT into the cloud. The internal project team they had at this stage consisted of the MD and the finance manager. Now, they both agreed their finance manager was spending 2 full days a week looking after IT problems when they had an IT contract that was supposed to sort out all the problems for them. But the staff couldn't wait for the IT company to respond, so the finance manager kept doing it. Now, interestingly, the finance manager was very reluctant to consider that as a cost. The MD did, because he knew he wanted more out of the finance manager, he wanted better analysis of the figures. He couldn't get them because he kept fiddling with the IT. So consider fixed and variable IT costs. Variable's important. One of the reasons for going to cloud is to allow rapid expansion and contraction if you need to. To understand the effects of that, you might need to understand variable costs. Now, as a company, Online 50 are a prime partner of the UK 200 group. It's an association of professional firms, mainly accountants, some lawyers. Their recent survey across the group, they do a survey normally every year, found that average IT costs in those professional firms was around £2,500 per person. So that includes cost of hardware, software, services, connectivity, in-house IT staff where they have them. Now, where we've carried out a like-for-like comparison for firms to move their IT into the cloud, we've found the typical cost of IT based on our cloud-sourced IT service that we offer is about 20 to 25% lower than that figure, including all of the other services they'd need to buy. They'd need software, they may need support contracts from those software vendors, etc. So that shows that a properly implemented cloud solution ought to be able to deliver cost savings. Interestingly, the feedback that I've had from a lot of professional firms who say they've moved their stuff to the cloud is that it isn't cheaper. And one of the reasons for that is a lot of them, what they've done is they've taken their in-house IT and they've got someone, normally the IT services company that looks after their IT, they've got them to host their own IT in a data center. So they're not benefiting from the combined infrastructure that a cloud provider would typically put in place. So in the first answer to the first question, can cloud computing really increase productivity and reduce costs? So we've shown that a well thought out and implemented cloud solution, like any IT solution, if you've got appropriate software and implementation, should not only increase productivity, but also reduce costs. But that does not mean that it will. Okay? Jumping onto the bandwagon of cloud, there's lots of people who say we've got a cloud solution. Jumping onto that bandwagon doesn't necessarily give you the benefits you're looking for. That doesn't mean that it won't, but you still need to be a discerning buyer. So we're going to move on to think about the second question, how people are using the cloud. We need to understand what the cloud is. The term's evolved over a number of years. We published a few years ago a white paper which we've since had to revise, looking at the roots of that term, because so many different people use the term to mean different things. Back in 1961, John McCarthy who was a professor at MIT, first coined the phrase utility computing, and cloud has evolved out of that. Now this definition here, this is from NIST, which is it's a department of the US government. This is their 16th and we hope final draft. Okay, so there's quite a lot of detail in that. They have 5 aspects of cloud, but a lot of people would call a solution cloud that doesn't necessarily meet their definition and wouldn't meet all of the 5 aspects. So although there's nothing wrong with it, we're going to use this definition from the Oxford English Dictionary, which is much simpler and says it's the process of processing and using data that's stored on the internet rather than in-house. So let's have a look at a cloud implementation. On the basis of the definition that we just looked at, we're going to need some users. They're going to be accessing their data, and their data is going to be held remotely over the internet. The users are going to need a user interface to work with. That user interface is going to have some user interface logic, and that will need to interact with application logic that actually makes the application work. Now, if you have the user interface logic and the application logic all running where the user is, that's what we'd normally call a client-server application. And it is possible often to run a client-server application with the data a long way away in the cloud, but the application locally. Where you move the application logic to where the data is, but keep the user interface and the user interface logic with the user, that's typically what happens with a web application. So the web browser is obviously presenting the user interface, running the scripts, etc., to make all of that work. It talks to application logic, which talks to the data remotely. You can also move everything into the cloud. So the user remotely connects to a user interface that's in the cloud, and that's presented to them through the cloud. And that's typical of a hosted application rather than a web application. So we're going to consider web applications and hosted applications and what the differences are. So first of all, with a web application, as we've seen, the user interface runs at the user. But in a hosted application, the user interface runs in the cloud where the data is. So what that means is in a web application, the software is running page by page, whereas the hosted application is running continuously. The web application typically needs more bandwidth because it's got to download the user interface logic and the data that it's going to work on and then upload it, whereas a hosted application is only going to look at the little bits of data that are required to carry key presses and screen updates. The web application downloads data to process and then uploads the data back to the server, whereas typically a hosted application has got live connection to the actual data. The web application will run in the browser only. Now, for most commercial cloud offerings that are web-based that you'll see, that means it's online only. Whereas a hosted application, typically you can run it online or offline if you choose to. So you'll notice that the way these solutions use the internet is quite different and therefore are well suited to different types of internet connection. Now, ISPs will sell you an internet connection. Typically, they talk about the throughput, the megabits per second that you can get. You might have a 20 meg, a 40 meg, 150 meg service. And that's really the amount of data, the throughput of the pipe, if you like. What it doesn't tell you is how long it takes data to get from you to the other end of the pipe, or the length of the pipe, or the latency is how it's measured. Now, these days, your internet is going to be in constant use without you being aware of it. You've got software updates, you've got antivirus updates, you've got emails being transferred backwards and forwards if you're not using hosted email, or even if you have, often they get pulled down. Lots of data transfer. So without you being aware of it, you could find that your internet connection gets heavily loaded. So then when you try and run a cloud application on top of that, whether it's web-based or whether it's hosted, then that's going to have an effect on the responsiveness of that application. Now, with something like a hosted application, depending on your service provider, it is possible to implement a system that will allow the data to be prioritized for that hosted application, which means even when the internet pipe is congested, the data will jump the queue and you'll still get a responsive service. That's only possible where the provider controls both ends of the pipe, because obviously you have to control the traffic at both ends. We offer a service like that. Some providers may be able to offer you that kind of service. So how do you choose the type of implication that's available for you? Well, first of all, you're going to be looking at specific software often. A lot of cloud solutions are actually software that's designed only to be written as a web application. So if you're considering that software, it is a web application. I would suggest always decide what you want and then evaluate your choices against the criteria that you've chosen. Avoid being trapped by a narrow viewpoint. It's quite common, I think, that you get people who say that a particular type of technical implementation is inherently superior to others. Now, different implementations might be better suited to your particular requirements, but that doesn't necessarily mean it's inherently superior to all others. Unfortunately, over the years, I've come across lots of people who do exactly that. And I got into trouble a few years ago because I described a conversation that people were having. I described it as being techno-fascism. Now, I'd just like to put my hands up. I never called anyone a fascist, okay? But what they were basically saying is that they wanted to redefine an industry term that had an accepted meaning to mean something else so that it would support their point of view to the exclusion of others, which only creates confusion. And if you say that one bit of technology is inherently superior and deserves to crush all other technologies, which is where the fascism bit comes in, all that's going to do is stifle innovation. That's not a good thing for anyone. For as long as people are choosing different systems, we'll continue to get innovation. Going to the cloud. Rip and replace or lift and go? That's a first question. You can choose to replace all of your systems with things that have been designed for the cloud, or you can say, we've got systems that work for us, how can we put those into the cloud? Now, typically, people can only cope with so much change at once. Change management is obviously going to be really important. So think about what it is you're doing and whether or not inherently that's going to work on terms of a change management program. Have a clear understanding of the benefits you want to achieve. We said that earlier. And spend time, if you can, trying to uncover the pitfalls. Now, trusted contacts can help. Okay, so you can ask people who've used the same system, how is that going for you? What was good, what was bad? Everybody is going to have issues where things haven't quite gone as expected. That's normal. But then what happens when things don't go as expected? What are the implications of that? So, as an example, again, a conversation I had on the stand yesterday, somebody was talking to me. He'd been speaking to one of his software suppliers who is here today about their software support, which closes at 5 p.m, which is quite normal. But he said, the software support issues we get always are when we apply the updates. And we always apply the updates out of hours because otherwise we have to shut down the office while people are working, which means always when we went to support, you're closed. That's an issue for him. Now, I have no idea how he's resolved that with his provider. Now, you can talk to suppliers. Bear in mind, obviously, suppliers may well have a vested interest in what they're telling you, so bear that in mind when you're talking to them and evaluating what they're telling you about the benefits and pitfalls of a particular approach. So the second question that we had, how are real-world companies benefiting from using the cloud? Well, lots of companies are going to the cloud. Some of them go the whole hog and put everything in the cloud. Some of them do particular applications in the cloud. Some reap considerable benefits, others may not. For other people, it can be a real problem if the solution they've chosen then doesn't deliver them the benefits that they want. Now, there are some benefits that are inherent to things being on the cloud. So, for example, being to access from multiple locations, provided the internet connection is adequate, being able to access from multiple locations is a given with the cloud. But as with any IT system, there's a potential for a change to go wrong. I don't want you to put you off going to the cloud. Of course I don't, I'm a cloud provider. But going to the cloud is not something that in and of itself will fix problems. The cloud can help you address IT problems that you've got with your systems, but only if you've identified those problems and you actually set out to resolve them. It's not a magic fix, it's not a panacea that's just going to suddenly make it work. In terms of what we're seeing, there is a split between people thinking about web-based technology and people thinking about hosted applications. As I've said, both can be completely viable solutions for you. They're inherently different, they work in different ways, and because of that, you're going to have a slightly different experience. Whether one is right for you will depend largely on the particular solution that you've opted for. Okay, we're going to move on. Time is, we're okay for time, but time is marching on. Planning for resilience, the third question, what if the internet fails? Well, what do we mean by that? I think, first of all, this is it's an operation in risk management. The way a typical risk management process works is you identify the risks, you rate the risks, you implement controls for that risk, and then you reassess the risk with the controls in place. And you repeat that until you've got the risk down to an acceptable level. So the risk that you want to look at the effect that it's going to have on your business and the chance of that happening. And ideally, the controls that you implement can be controls to reduce the effect of the risk as well as to reduce the chance of it happening. If you can have one control that does both, that's great, but typically you'll want to look at multiple controls. Now again, you're all accountants, you're all numerate, so this kind of thing is bread and butter for you all. So the basic probability shows us that if you've got two events, the chance of either of them happening, you sum the probabilities, the chance of both of them happening, you multiply the probabilities. So what does that mean? If we think about this as being, we've got 1%. If we think about we've got a server connected to the internet that we need to use, if that server loses power, we can't access it. If the server loses its connection to the network, we can't access it. So if it's got one power supply, one power feed into it, and one network connection, and there's a 1% chance of it going wrong, there's a 2% chance of the server not being available. You'd hope there's a much less than 1% chance for both of those things. But if you implement a server that's got multiple power feeds through different power supplies, you then multiply the chance of the power failing to become 0.01%. If you do the same with the network, that's 0.01%, it's now 0.02%, so you've drastically reduced the risk. So the clear answer to that is when you're looking at hosted systems and you're thinking about how those are going to work for you, you want to implement controls that survive the failure of individual components, because that's how you get ultra reliability. Now, I may have taken this a little bit too far, but I left home this morning knowing that I was going to have to give this presentation. It's not our laptop, I just needed to bring it. I thought I'll save it in two formats. I'll put it on two separate memory sticks. And you think, oh, what happens if I'm exposed to electromagnetic radiation? Well, I'll put them in different pockets, and if it gets both pockets, I've probably been electrocuted, which means I won't be giving a talk anyway. So a kind of tongue-in-cheek, slightly example of how you would go about doing that. Now, politics of risk reduction. One of the things we noticed, we started Online 50 over a decade ago, and at the time, people often raised security as a key concern. Now, information security covers three main things. It covers the availability of systems, the integrity of the data, and the confidentiality of that data. Most people mean confidentiality when they say security, but actually if the availability isn't there, it doesn't matter that no one else can get to the data because you can't either. So each of those three is really important. And what we're seeing now, with the cloud being much more prevalent, is worryingly, people assume things are secure. And I'm sure you all know, in life, you should never assume anything. So how do we know things are secure? It's actually very difficult to know. You're not necessarily going to know about all the measures somebody puts in place for the availability, integrity, and confidentiality of your data. But first of all, stop and think about what you're being told. Does it make sense? So, for example, you may be told our system is ultra secure, we're hosted in a military bunker. Now that sounds great. If you're worried about armed terrorists attacking the data center and making off with the servers that hold your data, a military bunker is a great place to put it. If you're worried about flooding, if that bunker is underground in somewhere like Berkshire that we've seen on the news is getting flooding, that's probably not a good place to put it. Okay, so stop and think about what's being said, because it's very easy to make statements that sound great, but actually when you pick away at them, you find there's not a lot of substance behind them. One of the other things to do is to try and assess which parts of the system are run by who. What recourse you have against people who are involved in the provision of the service that you've paid for, but who you don't have a contract with. So, for example, lots of people might say, we use an accredited data center. Okay, so what's the data center responsible for? The physical safety of the actual equipment. They're not responsible for the fact that one of their users might press a button and accidentally delete all of your data. Nothing to do with the data center, because they're not using it at that level. If the physical server is stolen, and the data center is supposed to be responsible for that, do you have recourse against the data center? Probably not, I would have thought. So if security and continuation of your service is important, these are the kind of things that you need to be asking yourselves about. So the third question, what if the internet fails? I think to answer that, we have to understand what is it we really mean. Is it a loss of the connection in your office? Okay, your phone line in the office, digger might dig up the road, destroy your phone line, you're cut off from the internet. So that's one risk. You may find that the service that you're offered by your provider has failed. So the internet's running, but the provider has failed. Particular components of the service might be unavailable. Data that you've got hosted with them might be corrupted. I hadn't heard of this, but a couple of people were talking on a stand yesterday. They use Dropbox, like lots of people do, and the people talking had both experienced files mysteriously disappearing out of Dropbox. Now, is that Dropbox, or is that because someone's deleted them? I don't know. I'm not saying there's anything wrong with Dropbox, but if your data's corrupted, you've potentially lost access to that data. And the bottom one, widespread destruction of infrastructure. So for the internet to fail, you've got to have massive failure of multiple systems in multiple locations. I mean, that's the kind of thing that's going to happen if somebody lets off a nuclear bomb. Okay, if somebody lets off a nuclear bomb, we've probably got other things to worry about. Now, that doesn't mean we shouldn't plan, but we've got to assess what's the risk and what's really going to happen as a result of that event, so that we can then think about, is our risk planning appropriate? So on the third question, what happens if the internet fails? The reality is that a properly planned and implemented system purpose-built for offering cloud services should be planned to offer high levels of resilience. That doesn't mean necessarily that it has been, and one way to check that is to look for what accreditation that provider has. I mentioned earlier that many of the firms who say they've gone to the cloud, what they've actually done is had their own IT equipment installed in a data center so they can access it. That's unlikely to have the same levels of resilience as it would have if it was a professionally managed solution purpose-built for cloud. Now, don't get me wrong, the data centers will have redundant power and there'll be, their internet connection will be much more reliable, etc. But inherently, you haven't designed that system in. It is possible. We talked about loss of connection to the internet. Obviously, if your local connection fails, you could always work somewhere else. That's one of the benefits of cloud. But it is possible to set up systems that can keep copies of the data in more than one place. Practically, there are lots of issues with that. Change control, who has access to the data when. With large numbers of users and lots of data, that can quickly become impractical. But it is possible, technically, to construct a system where your data is online, but also in your office. If you can't get online, you can switch to using it in the office. Big problem, though. Obviously, it depends on the data and what you're doing with it. What happens if you've got two offices? One can get online, the other one can't, and they're both changing different copies of the data. Well, that would depend on what the data is and how that's managed. So identifying what the risks are and how you can address those risks allows you to confidently say, our data will be more available, it will have better confidentiality and better integrity with a cloud provider than it would if we'd put it in-house. Okay. Before we go into questions, I know a number of you had some questions, and in particular people were asking about real-life scenarios. I'm very happy to talk about some case studies. Just quickly, what we're doing at Online 50 in regards to going to the cloud. We've got a range of services. I mentioned earlier we started over a decade ago. Our first service was a collaboration platform allowing accountants and their clients to work together on accounting software online. We've also got the cloud-sourced IT service, which is a go-to-cloud service. We talked about lift and go or rip and replace. This would be a lift and go service to help you put your IT in the cloud. IT services can still run in your building. Sometimes it makes sense for that to happen, and the two can be joined up in a single managed environment. It's implemented on a managed basis with change control, which gives you managed fixed costs on a monthly basis with known costs for projects to help you plan for the expansion or contraction of the business, which is, as we said earlier, one of the benefits of the cloud. Okay, I have raced through that a bit, but I have managed to finish with plenty of time for questions. So I know a few people were asking for case studies. I could trot a few of those out, but are there any questions from the floor on anything that I've asked? Okay, so let's think about some case studies. We worked a while ago with a firm of accountants based in the north of the country with one of their clients who were lawyers dealing with a lot of property, and they had specific software that they used which was part of that compliance work that they were doing. They wanted the benefits of being able to use that software, which was running in-house, but to use it online, and using it online would mean that they were able then to have people working from home, outsource jobs to people who were in different parts of the country. Obviously with the property market, sometimes a little bit of local knowledge goes a long way in terms of knowing, they see an address and they think that's built on the old gasworks or whatever. They might know that because they have local knowledge. So there was a clear benefit for them for going to the cloud. They implemented a service with us that we call the ECP service. That's a hosted server which you can have your own software installed on, but it's shared access for all users. The cloud-sourced IT service that I mentioned earlier gives you a separate environment for each user. So each user is, firewall is not the correct term, but you'll probably understand what I mean. Each user is firewalled off from the others. And what they found was the service was working fine, no problems, and then their software provider put on a software update on their software, and the whole system ground to a halt. And every user who used the software was trying to use 100% of the available resources on the machine, which obviously 100% times 18 users, that's not going to work. Now this was clearly a bug in the application software that the vendor had provided. Because of the way they'd chosen to implement it, as I said, they'd gone for this ECP shared environment, not for a cloud-sourced IT environment, there was no inherent protection for one user against another user consuming their resources. They found the system became inoperable. They said to the software vendor they wanted to go back to the old version. The software vendor said that cannot be done. Technically, we don't have the resources to do it. As a result of that, they started losing work and the company actually went into administration. So something that started out well, but because they then got a software update they weren't expecting, that the software vendor wasn't prepared to support, that had a disastrous effect on their business. Now the same accountant has another client, they work with us, they have the same solution, ECP. They've run a drinks company, so they produce lots of drinks, they sell through a lot of retail and leisure establishments across the country. They didn't have an effective way of working together. There were 4 main directors, minimal staff. They had drivers, but no real office staff. Implementing the system meant they could all work from home. For them, the ECP service has been absolutely fantastic. It's changed the way they work. It's enabled them to do all sorts of things. They take extended holidays with the agreement of their partners on the basis that they're going to have 2 weeks off, but then the next 4 weeks they're still away in wherever they are, but they're actually working because they're able to get online. For them, fantastic solution. Same solution. The key difference was that bit of software with a software vendor who gave them an upgrade that didn't work, who wasn't prepared to roll them back. Okay. Now, how would that have been different if they'd used the cloud-sourced IT service? Well, the cloud-sourced IT service, one, it has a built-in firewall. Firewall's not the right term, but users can't affect the operation of other users, so they would not have experienced the problem in the same way. Users might have experienced some slowness, but it wouldn't actually have ground the whole of their server to a halt. The second thing is, because of the way changes are controlled, to upgrade that database would have meant cloning the old database and then changing it, which would have meant we could have given them their old database as soon as they'd asked it and rolled them back to the server as it was before. That's not built into what they bought with the ECP service. Now the costing is different depending on number of users. At the lower end, the cloud-sourced IT service is going to cost a bit more, which is why they chose to go with the other service. At the higher end, the cloud-sourced IT service is actually cheaper. So it's determining what is the benefit and the risk profile for them. Okay, we still have a few minutes for questions. Any? You don't get how cloud is cheaper? Okay, so the question was, you don't understand how cloud can be cheaper. You've got the same software on-premise. I'm paraphrasing a bit what you said. You've got the same software on-premise, so you're paying for the same costs. When you put it into the data center, it's working out, I think you said 25% more is what you've seen. Cheaper in the data center. Okay, so you're saying if you put your own IT, in the data center directly, you'll pay less than putting it on the cloud. Okay. Now that would depend on what you're being charged to put it in a data center, obviously. From our point of view, the kind of service, we talked about cloud-sourced IT, the kind of service we implement cloud-sourced IT on, you may have heard of virtualization, but there's a virtualization platform that allows you to allocate subparts of that platform. The individual servers that make up that service, the ones that are available for sale now are about £45,000 each server. Okay, so the implementation costs, you're going to have at least two. Ideally, they fit into a blade center chassis. Ideally, you should have two chassis with at least two in each chassis. So your initiation costs, if you've got to buy that hardware because you're not using a cloud provider who's already bought it, are going to be enormous. Now, you may not be using that if you're just putting ordinary servers in, but then you've got to look at what is the risk profile of those servers going down. All I can comment on is the costings that we've done with people, and I'd be very happy to go through a costing with you that shows what we charge for the environment and what you would have to pay yourselves. If it's like for like, I mentioned the difference between the ECP type service and the cloud sourced IT service. So technically, the ECP is effectively running terminal services, or Citrix, people might think about it's a shared environment, it's one server. The cloud sourced IT is what they call a VDI. So everybody has got their own piece of infrastructure. There's a lot more infrastructure deployed. But what we found, as I said, typically is that we are 22 to 25% lower than the average cost of people. And on a like-for-like basis, that is the case. I can't comment on other providers, but to get equivalent, if you don't already have it, you've got to spend an enormous amount of money. And if it is cheaper, almost certainly that's not being included. And because it's not being included, you've then got to think, well, what is the resilience of that? You know, is the data as well protected? Is it as fast? Is there the same level of replication? I can't comment on an individual one, but it should, in my experience, be cheaper if you do it with the infrastructure. And what you may find, what lots of people do is they buy infrastructure for clients. So you're not using a common infrastructure. They've got a common architecture, but each time a client goes in and says, I want something, they buy more hardware and dedicate it to the clients. That can work well with large deployments, which typically VDI deployments are, but obviously you've then still got this big upfront cost, and you may find, I have no idea, but you may find in your scenario that's what it is. I'll be very happy if you're interested to go through the exercise of costing it and we can see. Okay, we are at 1:42, so I really need to wrap up to allow the next people to get going. Thank you very much. I haven't scanned anyone. We have no contact details for any of you, so we can't hound you, but if you would like to discuss anything in more detail, you can grab me now, or you can find me on the Online 50 stand. It's just next to the AVN stand just over here. Thank you very much for listening.